In this section, we will focus on understanding the fundamental concepts of security models, a crucial aspect of the CISSP Domain 3, Security Architecture and Engineering. Security models provide frameworks for building secure systems, ensuring data integrity and confidentiality. They guide the creation of security policies and help enforce access controls within an organization. As we delve into this topic, we will discuss several prominent security models, including the BIBA model, the STAR model, the Bell-LaPadula model, the Clark-Wilson model, the Brewer-Nash model, also known as the Chinese wall, and the Graham-Denning model. Each of these models plays a unique role in ensuring different aspects of security, such as preventing unauthorized data modification, separating conflicting interests, and maintaining overall system coherence. Understanding these models is essential for designing and implementing effective security measures that align with an organization's strategic objectives. In this part of our course, we'll delve into the fundamental concepts of security models, which serve as essential frameworks for constructing secure systems. These models are crucial in ensuring both data integrity and confidentiality in your security architecture. Let's look at some prominent examples. BIBA model focuses on maintaining data integrity by preventing data corruption. STAR model enhances both integrity and confidentiality with multi-level security protocols. Bell-LaPadula model protects confidentiality by restricting access based on security clearance levels. Clark-Wilson model ensures integrity through well-defined transactions and separation of duties. Brewer-Nash model, Chinese wall, prevents conflicts of interest by regulating access based on organizational roles. Graham-Denning model provides a framework for secure object management and access controls. Understanding these diverse security models will enable you to apply the right frameworks and methodologies needed to protect your systems comprehensively. Bruce Schneier's quote, "Security is not a product, but a process," encapsulates the essence of effective security practices. This means that security cannot be achieved through a one-time purchase or a single solution. Instead, it requires continuous effort, adaptation, and management. As we explore various security models, remember that these frameworks are tools and guidelines within a broader dynamic process. By integrating them into our ongoing security strategies, we can more effectively protect data integrity and confidentiality in our systems. The BIBA model is a crucial security model designed with the purpose of maintaining data integrity. Its primary objective is to ensure that information remains unaltered and consistent with its intended state. The key principle underpinning the BIBA model is the no write-up, no read-down rule. This means that a user at a lower integrity level cannot write information to a higher integrity level, and conversely, a user at a higher integrity level cannot read information from a lower integrity level. An example of where the BIBA model is prominently used would be in government systems. These systems utilize the model to prevent unauthorized data alteration, ensuring that highly sensitive information remains accurate and trustworthy. By adhering to these strict controls, the potential for data corruption or tampering by lower integrity users is significantly minimized, protecting the data's integrity effectively. This focus on maintaining integrity makes the BIBA model an essential component in the toolkit of security models for various high-stakes environments where data accuracy and integrity are critical. In this slide, we delve deeper into the BIBA model and its significance in ensuring data integrity. In essence, the BIBA model is designed to prevent data from being modified by subjects with lower integrity levels, maintaining the integrity of the information. To break it down, the model relies on two main rules. 1. Simple integrity axiom, no read down. This rule prevents subjects from reading data at a lower integrity level than their own, thus avoiding contamination from less trusted sources. 2. Integrity star property, no write-up. This principle ensures that subjects can't write to data at a higher integrity level. By doing so, it mitigates the risk of corrupted or unauthorized modifications being introduced into higher integrity data. To apply these principles practically, consider using a command like chmod 640/path to file. This command sets file permissions to ensure that users can only read and execute based on their designated integrity level, thus maintaining data integrity. Understanding these principles is crucial for implementing security models that prioritize data integrity, particularly in environments where the integrity of information is paramount, such as governmental systems. The slide we're looking at now presents an interesting fact about the BIBA model. Specifically, it highlights that the BIBA model is primarily used in scenarios where maintaining data integrity is more crucial than confidentiality. This makes it particularly valuable in environments where accurate and unaltered data are imperative, such as financial record keeping or industrial control systems. Understanding the key application contexts for the BIBA model assists in appreciating its strategic importance in security architecture and engineering. The STAR model is designed to address both confidentiality and integrity, integrating multiple well-established security models to create a comprehensive approach. This slide explains the purpose of combining these two crucial aspects of security. This is particularly useful in environments where it's equally important to maintain the privacy of information, as well as ensuring its authenticity and reliability. The versatility of the STAR model makes it applicable to systems that demand robust protection for both data integrity and confidentiality, making it a valuable framework in complex security scenarios. The STAR model is designed as a comprehensive security model, integrating both data confidentiality and data integrity by incorporating aspects of the BIBA and Bell-LaPadula models. This fusion ensures a holistic security approach. Its flexibility allows it to adapt to various security requirements, making it suitable for diverse environments. To provide a practical example, there is a command that implements the combined approach to integrity and confidentiality, set-enforce1. This command enables policy enforcement that upholds the key principles of the model. The STAR model is particularly useful for systems where both data integrity and confidentiality are critical aspects that need to be managed simultaneously. The Bell-LaPadula model is a cornerstone in the realm of security models, primarily designed to ensure data confidentiality. The key principle underpinning this model is succinctly captured by the phrase, "No read up, no write down." This means that subjects at a lower security level cannot read data at a higher level, no read up, and subjects at a higher security level cannot write data to a lower level, no write down. An exemplifying application of the Bell-LaPadula model is found in military systems where it is crucial to prevent unauthorized access to sensitive information. By adhering to these principles, the model effectively restricts data flow and access, thereby preserving confidentiality across various data levels. Remember, implementing these principles within a system can be achieved through commands like setfacle-m username r path/file, which configures access control lists to maintain the desired security posture. The Bell-LaPadula model is primarily focused on maintaining data confidentiality, ensuring that information is only accessible in a manner consistent with the user's clearance level. This model is known for its two core rules: the simple security property, which dictates no read-up, preventing users from accessing information at a higher classification level, and the STAR property, which enforces no write-down, restricting users from writing information to a lower classification level. To illustrate this in practice, let's consider a common command used in Unix-like operating systems to set user access levels: setfacle-m username r path to file. This command modifies the file access control list, AC grant read permissions to the specified user. By implementing such commands, organizations can ensure that user access strictly adheres to the policies laid out by the Bell-LaPadula model. In essence, this model is a fundamental component in systems requiring stringent data confidentiality, such as military environments, to prevent unauthorized data access and leakage. The Bell-LaPadula model is noteworthy for being one of the foundational formal models in computer security policy. Established to maintain data confidentiality, this model sets the groundwork for how information access is governed based on varying clearance levels. It introduces two primary rules: the simple security property, which prevents reading information at higher security levels, no read-up, and the SAS-STAR property, ensuring users cannot write information to lower security levels, no write-down. Such conceptual rigor helps in implementing robust security practices, as exemplified by access control commands like setfacle to regulate file permissions. This model's pioneering approach underscores the importance of structured, rule-based security frameworks in protecting sensitive information. This contribution remains pivotal as we explore additional models addressing other security aspects, such as data integrity and transaction correctness. The Clark-Wilson model focuses on data integrity by ensuring that transactions are carried out correctly. The primary aim of this model is to maintain the integrity of data and ensure the correctness of each transaction. It emphasizes well-formed transactions, which are procedures that transform data from one consistent state to another. This model is widely used in financial systems where the accuracy and reliability of transactions are critical. By implementing the Clark-Wilson model, organizations can safeguard against errors and fraudulent activities, thereby ensuring that only authorized users and programs can modify data. Now let's dive deeper into the Clark-Wilson model. This model ensures data integrity by enforcing a separation of duties. It's crucial because it makes certain that data is modified in a well-formed manner. The model sets rules to ensure that only authorized users and programs can modify data, making sure the interactions are legitimate and controlled. An example command to implement the principle of separation of duties could be chmod 750's path to transactions script. In this command, the permissions set using hmod restrict unauthorized access, allowing only specific users to execute the transaction script, thereby upholding the integrity of the data. Ultimately, the Clark-Wilson model is highly effective in scenarios requiring stringent transaction correctness, like financial systems where maintaining the integrity of data is paramount. The Brewer-Nash model, also known as the Chinese wall model, is designed to prevent conflicts of interest. Its primary purpose is to restrict access in a way that prevents users from accessing conflicting datasets. This model is particularly useful in environments where handling sensitive information from multiple clients could compromise integrity or confidentiality. The key principle behind the Brewer-Nash model is dynamic access control based on user activity. Essentially, if a user interacts with one set of sensitive data, they are precluded from accessing another set of data that could present a conflict of interest. This dynamic restriction helps ensure that decisions and actions remain unbiased and that confidential client information is kept secure. For example, consulting firms that serve multiple clients can implement this model to ensure consultants do not access conflicting client data, maintaining the integrity and trustworthiness of their service. This model effectively helps in managing the access controls dynamically, thereby protecting the interests of various clients being served by the same firm. By understanding and implementing the Brewer-Nash model, organizations can create a secure environment where conflicts of interest are systematically avoided, thereby promoting fair and unbiased decision-making processes. The Brewer-Nash model, also known as the Chinese wall model, offers a method for preventing conflicts of interest within organizations by dynamically controlling access based on a user's activity. This slide delves deeper into how this model operates. Firstly, it emphasizes conflict of interest prevention. Users are prohibited from accessing data that conflicts with other information they have already accessed. Essentially, access to one set of data automatically precludes access to conflicting data, ensuring sensitive information remains compartmentalized. For instance, in a consulting firm handling multiple clients, an employee granted access to Company A's sensitive data would be restricted from accessing any of Company B's sensitive data, provided that access to both could create a conflict of interest. A practical example command shows how this restriction might be implemented at the system level. Set facu username mask-path to conflicting's data. This command modifies the file's access control list ACL, removing the execute permissions for the specified user username to the path containing conflicting data. In summary, the Brewer-Nash model leverages dynamic access control rules to maintain integrity and prevent conflicts of interest within an organization's security framework. In this slide, we're looking at an overview of the Graham-Denning model. This model is integral in defining a set of rights for secure object management within a system. The primary focus here is on rights and privileges management, which is essential for implementing robust security policies. By specifying the rights that subjects, like users or processes, have over objects, such as files or devices, the Graham-Denning model supports detailed control over access management. A practical example of where this model shines is in systems that require meticulous access control policies. For instance, environments that need different levels of access permissions for different users will benefit from having a clear and structured rights management system. Through these defined rights, the model helps in managing who can perform specific actions on various objects within the system, thereby enhancing security. As part of your CISSP 2024 training in Domain 3 on security architecture and engineering, understanding this model will provide a solid foundation for creating secure systems by meticulously managing access control policies. The Graham-Denning model outlines the mechanisms and rules that govern access rights management and secure object handling within a system. This model identifies 8 primitive protection rights, which include the ability to create and delete objects and subjects, as well as to read, grant, transfer, and delete access. To provide a clearer understanding, let's look at an example command used in Unix-based systems for managing access rights. bash chown user group path to resource cmod 700/path to resource. Here, chown changes the ownership of a resource, and cmod 700 sets the permissions such that only the owner has read, write, and execute rights. Such commands illustrate how access rights can be explicitly managed to ensure that only authorized subjects can interact with specific objects in the system. By following the rules and principles outlined in the Graham-Denning model, organizations can implement effective rights and privileges management mechanisms to enhance their security posture, particularly in environments that demand rigorous access control like government, military, and financial sectors. In this slide, we're focusing on the practical application of security models. When implementing security models, it's crucial to understand the specific security needs of your organization. These needs will guide you in choosing the right model for each context, ensuring that your security measures are both appropriate and effective. Let's consider some real-world scenarios where different security models might be applied. For example, in government and military sectors, classifications like top secret or confidential dictate the controls needed for information protection. Financial sectors, on the other hand, require stringent controls to prevent unauthorized access and ensure the confidentiality and integrity of sensitive data. Understanding the context in which you're applying these models will help in effectively safeguarding against security threats and ensuring compliance with regulatory requirements. In essence, the right choice and application of a security model can significantly fortify an organization's defense mechanisms. In conclusion, security models are fundamental for maintaining the integrity and confidentiality of a system. Proper implementation of these models is crucial to protect against unauthorized access and modifications. As you move forward, it's essential to engage in further reading on the various security models and participate in practical exercises to solidify your understanding of these concepts. This will enhance your ability to apply these models effectively in real-world scenarios, particularly when preparing for the CISSP 2024 training focused on security architecture and engineering. In this slide, we provide a comprehensive list of references that will support your understanding of the fundamental concepts of security models covered in Domain 3 of the CISSP 2024 training. The sources include official CISSP study guides, which are essential for your certification preparation. Additionally, to deepen your knowledge, we recommend diving into security model research papers, which offer detailed analyses and theoretical foundations. Finally, practical examples and case studies will help you see these concepts in action, making it easier to grasp their real-world applications. Now let's examine the current question on the primary focus of the BIBA model. The BIBA model is one of the key security models you'll encounter in the domain of security architecture and engineering. So what is the primary focus of the BIBA model? You have three choices here. A, confidentiality, B, integrity, C, availability. Take a moment to think about it. The BIBA model specifically aims to ensure that data is not altered by unauthorized entities, safeguarding its accuracy and reliability. This emphasis is crucial in environments where data integrity is paramount. Choose the option that aligns best with this focus. Answer 1. The correct answer is B, integrity. The BIBA model focuses on maintaining data integrity by ensuring unauthorized users cannot modify data. While it contrasts with models that emphasize confidentiality, its primary purpose is to safeguard the accuracy and trustworthiness of information, thereby preventing corruption and unauthorized alterations. Understanding the BIBA model's focus on integrity is crucial for constructing a robust security architecture, as it highlights the importance of protecting data from unauthorized changes. Question 2 asks us to identify the security model that integrates aspects of both the BIBA and Bell-LaPadula models. Your options are A, Brewer-Nash, B, Clark-Wilson, C, STAR model. Understanding the key attributes of these models is crucial. The BIBA model focuses on data integrity, ensuring that information isn't improperly modified, while the Bell-LaPadula model emphasizes confidentiality, controlling access to classified information. Given these perspectives, the model that combines both integrity and confidentiality principles is the STAR model. This hybrid approach allows for a more comprehensive security framework by integrating the strengths of both the BIBA and Bell-LaPadula models. This concludes the content for this slide. The answer to question 2 is C, STAR model. The STAR model stands out because it integrates key elements from both the BIBA and Bell-LaPadula models, effectively creating a comprehensive security framework. The BIBA model primarily focuses on data integrity, ensuring that data is not altered inappropriately, whereas the Bell-LaPadula model prioritizes data confidentiality, preventing unauthorized information flow. By combining these principles, the STAR model provides a robust approach to safeguarding both the integrity and confidentiality of data. This makes it particularly useful in environments where a balanced and thorough security posture is needed. In this slide, we have a question focusing on a key principle of the Bell-LaPadula model. This model is widely recognized for its emphasis on maintaining data confidentiality within a hierarchical environment. The question asks, what is a key principle of the Bell-LaPadula model? Option A, no read-up, no write-down. Option B, no write-up, no read-down. Option C, dynamic access control. Think about which choice aligns with the core philosophy of controlling data flow in a manner that prevents unauthorized access to sensitive information by users with different clearance levels. This foundational aspect of the Bell-LaPadula model helps ensure that sensitive data remains protected within designated boundaries. The answer to question 3 is A, no read-up, no write-down. The Bell-LaPadula model is designed to ensure data confidentiality by enforcing strict access controls. Specifically, it prevents users at lower security clearance levels from reading data at higher levels, and it stops users at higher security levels from writing data to lower levels. This principle ensures that sensitive information remains protected and inaccessible to unauthorized users, thereby maintaining the integrity and confidentiality of the data. This model is particularly significant in environments where classified information needs stringent controls to prevent data breaches and leaks. Understanding this principle helps to secure systems effectively by implementing proper data access policies. Question 4 addresses which model is primarily employed in financial systems to ensure correct transactions. The options given are A, Clark-Wilson, B, Biba, C, Graham-Denning. Each of these security models serves a different purpose. It's crucial in financial systems to enforce stringent measures for data integrity and control. The Clark-Wilson model, for example, is known for its rigorous enforcement of separation of duties and focusing on ensuring data integrity via well-defined transactions. Understanding these distinctions is key for implementing the appropriate security measures based on specific requirements in financial environments. Answer 4. The correct answer is A, Clark-Wilson. Explanation: the Clark-Wilson model is specifically designed to enforce separation of duties and ensure data integrity, making it particularly suitable for financial systems. This model requires that users perform transactions through well-defined programs, mediating all access to data to prevent unauthorized modifications. This ensures that all operations are executed in compliance with predefined rules or constraints, providing a reliable and secure framework for financial transactions. Question 5 on this slide asks, what does the Brewer-Nash model aim to prevent? Your options are A, unauthorized data modification, B, conflicts of interest, and C, data leakage. Think about the context in which the Brewer-Nash model is applied. It's specifically designed to address issues that can arise when handling sensitive information within companies, particularly to ensure that no conflicts of interest occur. Consider this when selecting your answer. Answer 5 is that the Brewer-Nash model aims to prevent conflicts of interest. This model dynamically controls access based on user activity, ensuring that individuals can't access information that would create a conflict of interest. This dynamic approach is essential in environments where user roles and activities may change, necessitating real-time adjustments to access controls. Understanding this model is crucial for implementing robust security architecture and engineering frameworks that mitigate risks associated with conflicts of interest. CISSP 2024 Training. Domain 3, Security Architecture and Engineering, continues to delve into these critical concepts to help you master security models. If you've been finding the content engaging and insightful, please show your support by leaving a like. Your feedback is invaluable to us, so feel free to comment below with any questions or observations you might have. Don't forget to subscribe to the channel to stay updated with the latest in our CISSP 2024 training series. Sharing this with friends and colleagues who might benefit from this training can help them as well. Your participation and interaction help us bring more quality content in the field of security architecture and engineering.